The lesson will cover how to solve equations when you have like terms in your problem. So we're going to start off by looking at the AQ, which is how does like term change the way you solve equations. So you've covered how to solve equations using two steps. We're going to go ahead and talk about when you have equations with like terms. So let's describe what like terms look like and give you a couple of examples. So the first thing we're going to be looking is uh, like terms that you've seen before, but you haven't maybe didn't refer to them as like terms. So the first type of like terms that we have are constant like terms. And those are when you don't have any variables in your problem. So constant like terms are just those terms or those numbers that you see in the equation that don't have any variables. So those are one type of like terms that we're going to be having. Let's give you an example here of what those uh, could look like. So basically it's just any number. For example, let's say that we have positive 4 and you had another problem with positive 1 or whichever other number that didn't have a variable. So in this case, let's look at negative 4 and 5. Those are like terms. Since one of them is negative, the other one's positive. Instead of adding them, we're going to subtract them. We have more positives. So my answer is going to be positive 1. What's important to remember here is that constants are those terms in your problem, in your equations that don't have any variables. So that's one type of like terms that we could have in our equations. The other type of like terms that we can have is when we have like terms with variables. So these type of like terms are the terms that you see in your equations that have a variable. For example, if you have x as your variable. And it could be any variable. Usually though, the problems that you guys will see is the problems that have x as their variable. So again, these terms are going to be the terms with their variables. So let's say that I had 5x and 9x as part of my equation. So these two will be like terms because they both have an x next to them. So since they're like terms, I'm able to combine them. They were both positive, so I just simply added those two numbers. The numbers before it, those are called coefficients. So I just added the coefficients. So I added the 5 and I added the 9. So again, we're going to have two different types of like terms when we are solving these equations, the ones with the variables, the ones without the variables. So every time you have like terms in your problem, we're going to go ahead and combine them by adding them or subtracting them before we start using the inverse operation. So we're going to go ahead and combine those like terms. So combine first before you're doing inverse operations. So that's the first thing we're going to look at. So I'm going to highlight my like terms here, which is the 9 and the 6x. Now, let's take a note of this here. When I say combine them first before doing inverse operations, they have to be on the same side of the equal sign. So sometimes it helps if you draw a line through the equal sign and it separates the right side of the equal sign and the left side of the equal sign. So I'm going to combine those like terms that are both on the right side of the equal sign right now, which is the 9x and the 6x. So it says 9x minus 6x, that will give you 3x. We're going to bring down the 15 here and rewrite the rest of our equation. So I suggest that if it confuses you how to separate your two different sides of the equations, just draw that line. And we know that whatever we do to one side of the line, we're going to do to the other side of the line. So in this case, we're going to cancel the adding 5 by subtracting 5 from both sides. And then we're just going to bring down the 3x. On the left side, we have two negatives, which means I'm going to be adding them. And I get negative 27. The last inverse operation that I need to do is divide by 3. So we're going to get x equals -9 because a negative divided by a positive, it's a negative. So that's our answer for the first equation, x equals -9. And your x can always be on the right side of your equation or on the left side of the equal sign. It doesn't matter. So let's go ahead and split those two different sides on the second problem. We're going to be looking for the like terms on the left side, which is where your variable is. So -3 and -4 are like terms because they both don't have a variable next to it. They're both negatives, so I add them and I get -7. We're going to bring down the AB and the rest of the problem as well. So now it becomes a two-step equation. We're going to do the inverse of subtracting 7, which is adding 7 to both sides. That cancels the 7 on the left side, so we can cross that out. We're left with AB. And on the right side, you have a negative and a positive. Since we have different signs, we subtract them and we get 16. Negative because you have more negatives. And then the last inverse operation that we're going to do is divide by 8, since that's the number next to the B. So now we have B equals -2, a positive, or a negative divided by a positive, it's a negative. So that's the answer for the second equation that we have here. Now, sometimes, as you guys will see in the second problem, we won't always be able to combine the like terms first. So sometimes we have parentheses in our problem. So we're going to be using structure to solve this multi-step equation here. And what that means is, and we're going to write that little note on the side. If you see parentheses in your problem, we're going to distribute first and then combine like terms. So it's important that we get rid of the parentheses first. Just PEMDAS says we do parentheses first, right? By distributing the number that's outside the parentheses to the terms inside the parentheses. So it means we're going to be multiplying. So we multiply depending how many terms we have inside the parentheses. So multiply the number outside with the parentheses with the numbers inside the parentheses. Careful if there's a negative sign or a minus sign outside the parentheses, because that means we're multiplying by a negative number. So in this case, we're going to distribute the 2 to the inside of the parentheses. So 2 times 1 is 2. 2 times x is 2x. We're going to bring down that minus sign, so the 2x will be a negative. We're going to draw that line to see if we need to combine any like terms. So we're going to split that side to the left side and the right side of the equal sign. We have some like terms here. We have a 2 and a 3 without a variable. Those are constant like terms. If we add them, because they're both positives, we're going to get 5. And then we're just going to bring down the rest of the problem. All right, so let's write down the rest of the problem there. And then we're going to start doing inverse operations to leave or to isolate our variable. So we're going to do -5 on both sides to undo the +5 there. So let's cross it out because it becomes 0. Then we're going to bring down the rest of our problem, which is the -2x. Make sure that you take that minus sign, which now becomes a negative, with the 2x. The 8 and the 5 will be adding, since we are adding two negative numbers here. And then the last inverse operation that I need to do here would be dividing. Every time you guys see two numbers together, or a number and a variable, that means multiplication. The inverse operation of multiplying is dividing. So we're going to divide here, divide on the other side. That would become a 1 on the left side. Negative 2 divided by negative 2 is 1, so that gets rid of our number before the x. So we're just going to have x equals, the 2 doesn't go into the 13 evenly, so we can just leave it as a fraction. So we're going to have negative 13 over 2. You guys can leave your answers as a fraction. Just make sure that you always go back and see if your fraction can be reduced. In this case, there's no number that goes into 13 and 2, so it stays the same. So we're going to go ahead and do the rest of the practice problems. So the last problem on there that you see is an error analysis. So I want you guys to make the corrections and explain what's wrong.